All right, so we did that one, and okay, so this means I don't know why I never like did the what it means. All right, so we got um 0.22, right? 8. This 5 makes that 8. All right, and that means that it's move the decimal place over twice. 1, 2. And you get 2.28% of people are going to use their cell phone for less than a year. Um, and this is, remember, 2 standard deviations is pretty unlikely. And it's not necessarily going to happen that much. All right, so let's look at another one. A survey indicates for every trip to the supermarket, the shopper spends an average of 45 minutes. All right, so that's X. Not X, sorry. And mu is population standard deviation. Population mean. The standard deviation is 12. All right, that's sigma. The length of time the store is normally distributed and represented by the variable x, shoppers into the store. All right, find the probability that the shopper will be in the store for each of these interval times, interpret blah, blah, blah. All right, so we want to figure out between 24 and 54. It's going to be x and x. We can do a couple of things. You can use the z-score formula, okay? And we'll get these two guys. Then we're going to subtract. We'll get those two guys. We go and look that up on the chart, and that's what we get. Or we can, I didn't do a picture. We can do it on a calculator. Right, and so we would do 24, 51, comma, mu is mu is 45, standard deviation times 12. All right, so I'm going to go on my calculator. I'm going to do second bars, that's the distribution stuff. I'm going to go to that CVS and I'm going to type those numbers. So 24, comma, 54, comma, 45, comma, 12. Oh, times 10 in front of it. All right, and I get the exact same thing, 0.773. Okay, there he is, 0.773. And I'm done. All right, so 0.773, that means one shopper is 73% likely to spend between 24 minutes and 54 minutes in the store. Okay, now let's say there's 200 people. Okay, so I'm going to do this part now. Okay, and if the percentage is, or the probability is 0.773, I'm going to take 200 times 0.773. I get this number, but you should round up because you can have 0.66 of a person. And so what we really get is that point is 147 shoppers. So of the 200 shoppers, 147 are going to spend between 24 minutes and 54 minutes in the store. Okay, let's do it again. Same concept, right? Shopper spends 45 minutes, 5 minutes. Standard deviation is 12. Standard deviation is 12. And what we want is more than 39 minutes, so 39. And so I can use the Z formula. I get negative 0.5, and then I take that negative 0.5 and I look it up on the chart. Because it's more than, it's to the right, on the right side of the graph. I'm going to do 1 minus that, and I get 0.69. All right, but we could also do our calculator. Okay, so we would do that like normal CDF is to the right, so 39 would be the smallest number. 10,000, then the mu, so 45, then the standard deviation sigma. That's mu, standard deviation. All right, so let's do that. Let's do second vars, go to normal CDF. $39, comma. Remember that 10,000 is just a blanketed. 3, comma, 45, comma, 12. We get the exact same number. There's my mouse. 0.69. It's the exact same number as I did if I did my hand. All right, so that means that somebody comes into the store, it's 69%, 69.15% likely that that person's going to spend more than 39 minutes. So if we have 200 shoppers that come in the store, we're going to take the 200 and times that 0.6915. That's the probability for one shopper. We want to know the probability of 200 shoppers. And so we're going to take that and do 138.3. I mean, we're going to get 138.3. I change this. Can't have, you always round up. So 139 shoppers in the store, more than 39 minutes. All right, let's do these concepts again. I want to go back to that problem that we did, I don't know, a couple of videos. It's taking a long time for me to describe, just like give you the full picture of this concept. All right, so we still have like the mean ACT score, the SAT score, and that information. And so we're going to find these things. Probability individual takes ACT is lower than 30. What percent take it? That's between 11.2 and 30, lower than 1400 between these two scores. Okay. Hang on. I'm going to do a right. All right, we can do a couple of things. I can draw it out, and I can do it by hand, or do the normal CDF, do my lowest bound. All right, 30 is the bigger number, and then I want everything lower than that. Then I take my mu, my mean, so 0.8, and then I take my standard. All right, I'm going to do that. Hopefully you're doing it negative 10,000, 30, 8, almost get 97.97. All right, so the probability that an individual taking the ACT would score lower than 30 is 97%. All right, what if we had, 125 people taking it? We had 125 people taking the test. I want to see how many would score below, on average, score below 30. I would take this 97.97 and times it by, did I say 125 people? And so that means that 121.5 or 122 people would score lower than 30. Okay, let's do. I'm going to do C, and then I'll come back and do those others. Let me do C. Probability individual taking the SAT would score lower than 1400. Let's do, let's change this just to vary it up. All right, so we will do the normal CDF. That's an F. Looks like a G. All right, higher than 1400. So 1400 is slower than what they want, comma. All right, the mean is 1500, and the standard deviation was 250. I'm going to type that in my calculator. Normal 1400, 10,000, 1500, 250. Get 0.66. It rounds. Okay. So one person, if they scored higher than 1400, that's 66% chance of that happening. Let's say 125 kids took the test one Saturday. And they want to know about how many kids of that 125 would score higher than 1400. And it's 81.9. Okay, so that's 82 students would score. Of the 125, 82 students would score higher than 1400. All right, let's do B and D. So I'm going to draw. I'm just going to show you how I do these two problems. All right. This is just the normal curve that we do. All right, ACT 20.8, 20.8. All right, 25.6, 30.4, 35.2, 20.8 minus 4.8. All right, we get 16, 11.2, 6.4. Okay, I'm going to go ahead and also do the SAT. So this was ACT, red. I'm going to align the SAT. So in the center was 1500 and the difference was 250. All right. And so we want to know between 11.2 and 30.4. All right, 11.2 happens right there. 30.4 happens right there. Remember, 2 standard deviations. All right, so 2 standard deviations is not that, it's 95%. So 95% of the population that takes the ACT test is going to score between an 11.2 and a 30.4. Oh, I don't, did I say 68%? I'm at 95%. I don't, I feel like what I just said was wrong. I don't remember what it was though. Okay, it'll come back to me. So for the SAT, I did the ECT in yellow. SAT, we want to know between 1250 and 1750. All right, that happens here and here. And that's one, look, it's 1 standard deviation. Like these guys were 2 standard deviations. All right, and so our rule was 68% of the data is 1 standard deviation. So 68% of the data, 68% of the population that takes the SAT score, the SAT test, is going to score within that 1 standard deviation, which is 1250 to 1750. All right, let's do finding z-scores, which is the direct opposite of when you're given a z-score and you find the area. So we have the area, okay? And we need to go look on our test, on our z-chart, 36.32. We're going to go there and then this way. Versus before, we started here and met up in the middle. Okay, if you want to do it on the calculator, we can. It's right here. And so, all right, so I went second vars, second distribution. Okay, and see the third one? That's the one we're looking for. So I'm going to scroll down, and it does the z-chart backwards. And so we had already 3632. 0.3632. Okay, and then when I hit it, I get negative 0.35, which is what they got. Okay, which is negative 3.5, which is what they got. And then we can do do the same thing. So